Hello, welcome to Succeed e-learning app. Today we are going to learn about the areas related to circle. So what is the importance of learning areas related to circles? In our day-to-day life, we come across several objects which are circular in shape. For example, be it your cycle wheel or a tire of your scooter, or be it bangles that the girls wear, or even be it the pizza that you all eat. All of these has circular shapes. Calculating various properties of circles such as radius, diameter, perimeter or the circumference and the area of circle will help you with resolving a lot of real life situations. For example, if you have to calculate the circumference of a planet, it will actually help you identify the relative sizes of the planets and also the diameter at which a planet or a satellite has to orbit around the planet when it is launched from the Earth. If at all you take a pizza, the size of the pizza will be calculated basis the diameter of the pan with which the pizza is being baked. Before looking into the practical uses of area of circle, let us quickly see the areas related to different sizes and shapes. Let us quickly look into the formula table. Perimeter and area of a circle. Let us quickly recap what we had learnt about perimeter or also called as circumference of a circle. In your previous class, you had learned that if a circle is cut at any one point and if it is placed on a plane, the length of the line is nothing but the circumference of a circle. Circumference of a circle bears a constant ratio with its diameter, and this ratio is denoted by a Greek letter pi. So if you look at this, circumference divided by the diameter is equal to pi. Now let us cross multiply. We get it as circumference is equal to pi times the diameter. So we all know the formula for diameter is 2 times of radius. Now if you substitute it here, it will become pi into 2 into r. If you rearrange, the circumference of a circle is equal to 2 pi r. Area of a circle can be calculated by using two methods. Let us look into it. Method 1 is by using the area of a rectangle, and method 2 is by using the area of triangles. Now to start with, let us see how we are going to calculate the area of circle by using the areas of a rectangle. Consider a circle with a point O at the center. Now cut this circle into 16 equal sectors. If you see here, the radius is denoted by r and the circumference of a circle, as we have already known, it is equal to 2 times of pi r, that is 2 pi r. Now let us take the cut pieces, that is the 16 sectors, and place it in a plane in a form of a rectangle. Now if you see that the length is pi r and the height is nothing but r, that is the radius. Now this is in the form of a rectangle. So what is the formula for calculating the area of a rectangle? Area of a rectangle is given by length into breadth. Now if you see here, the length is pi r and the breadth is r. When you multiply the both, you get area of the circle is equal to area of the rectangle, which is equal to pi r square. Now moving on to the second method, that is calculating the area of a circle by using the area of a triangle. Let us quickly consider a circle. Now split it into multiple circles and cut it at one end. Now on a plane, place it in such a way that it is stretched out and looks like a triangle. That is as you see in this picture. Now if you see that the base or the length is given by the circumference, the maximum length of the thread of a circle. So that is equal to 2 into pi into r. Now the radius is nothing but r. So, area of a triangle, as you all know, is given by half into base into height. Now, here the base is 2 pi r and the height is r. Substituting that in the formula, you get which is equal to half into 2 pi r into r. 2 and 2 gets cancelled. Therefore, the area of triangle is again equal to area of the circle, which is equal to pi r square. Now, let us solve some problems in order to apply the knowledge that we have learnt. First problem is on the board here. The cost of fencing a circular field at the rate of rupees 24 per meter is rupees 5,280. The field is to be ploughed at the rate of rupees 50 paise per meter square. Find the cost of ploughing the field. Consider pi is equal to 22 by 7. Let us see how we are going to solve this problem. So, in the question they have given the total cost is 5,280 rupees and the rate is 24 rupees. Now, length of the fence in meters is given by total cost divided by rate. Substituting the values, we get 5,280 divided by 24, which is equal to 220. So, the circumference of the field is equal to 220 meters. Therefore, if r meters is the radius of the field, then 2 pi r is equal to 220. Substitute the value of pi as given in the question. So, pi is equal to 22 divided by 7. This can be given as 2 into 22 divided by 7 into r is equal to 220, or r is equal to 220 divided by 2 into 22 whole multiplied by 7. Now, 22 ones are 22 and 22 tens are 220. Now, 10 by 2 is equal to 5. 5 into 7 is 35. Therefore, the radius of the field is 35 meters. Area of the field can be calculated by using the formula pi into r square. Now, we have got the value of r as 35 meters. Substituting it here and also substituting the value of pi, we get r square is equal to 22 divided by 7 into 35 square. So, this is equal to 22 into 5 into 35 meter square. Now, the cost of ploughing 1 meter square of the field is being given as 50 paise. So, the total cost of ploughing the field will be equal to 22 into 5 into 35 into 0.5, which is equal to 1,925 rupees. Areas of sectors and segments of a circle. In your previous classes, you have learnt what are sectors and segments. If you recollect, sectors are a portion of a circle which is enclosed by 2 radii and the arc of a circle. And segment is again a portion of a circle which is enclosed by the chord and the arc of a circle. Now, let us consider a circle with the center O. If you observe the picture here, OPAB is the sector of a circle, where OA and OB are the radii of the circle. Now, angle AOB is nothing but the angle of a circle, or you can also call it as the angle of a sector. If you closely observe, AOQB is also another sector of a circle. Now, what is the difference between these two sectors? If you observe that one of it is smaller than the other. So, the sector which is smaller is called as minor sector, and the sector which is bigger is called as major sector. The angle of the minor sector is considered as angle AOB, which is theta. Now, how do we calculate the angle of major sector? we know that an angle of a circle at its center point is 360 degree. Therefore, angle of major sector is equal to 360 degree minus angle of AOB, which is theta. That is 360 degrees minus theta. Consider another circle with the center O. Now, draw a chord AB and mark 2 points P in one of the segment and Q on the other half. Now, if you closely observe there, AB is a chord and APB is the segment. Also, AQB is another segment. So, again, applying the logic, the one which is smaller is minor segment, the one which is bigger is major segment. Therefore, APB is minor segment and AQB is major segment. Now, let us calculate the area of segment and the sector using this knowledge. To calculate the area of a sector of a circle, now let us quickly consider a circle. Divide it into two equal halves. If you see there, the line which is dividing it into two equal halves is nothing but its diameter, which is 2 times the radius. And if you observe the angle at the center of the circle, that is 180 degree. Now, area of these two segments can be given as half into pi into r square. Why is that? We know that area of circle is given by pi r square. Now, we are cutting the circle into two equal halves. So, we can write it as half into pi r square. Similarly, if you take a circle and cut it into 4 equal halves, so each of the half will have its angle as 90 degree, that is right angle. Now, apply the same logic as you learnt. We divided it into two halves, so we wrote it as 1 by 2 into pi r square. Now, we are dividing it into 4 equal parts, therefore, we will write it as 1 by 4 into pi r square, which is again can be written as in terms of angle as 90 divided by 360 degree. 360 because the circle will have 360 degree as angle at its center, and when it is divided into 4 equal halves, we got it as 90 degree. So, which is equal to 90 degree divided by 360 degree into pi r square, which again comes to 1 by 4 pi r square. Now, consider a third circle. So, here we are not dividing it into any equal parts. We are just considering one sector, okay. See this shaded region. It has been covered by two radius, that is r and an arc. Imagine if this angle of the minor sector is theta, we can write it as theta is equal to 30 degree. If suppose, we can write it as 30 degree divided by 360 into pi r square, which sums up to 1 by 12 into pi r square. So, if you consider and generalize the angle AOB as theta, then we can give the area of the sector OAPB as theta divided by 360 into pi r square. So, this is the formula of calculating area of a sector. Now, you have learnt how to calculate the area of a sector. So, how do we calculate the length of the arc which is in the sector? This can be calculated as theta divided by 360 degree into 2 pi r, where r is the radius of the circle and 2 pi r together is the circumference of the circle. Moving on to calculate the area of a segment. Consider a circle with the center O. It has a chord AB which has divided the circle into two different segments. One segment is APB and the other segment is AQB. Now, the area of the segment APB, that is the shaded region, can be calculated as area of the entire sector, that is OAPB, minus, if you observe there is a triangle which is formed between the radii and the chord. So that is nothing but area of triangle OAB. This is the formula for calculating the segment area of APB. Now, area of the major sector OAQB is equal to pi r square, that is the area of the circle, minus area of the minor sector of OAPB. Also, area of the major segment AQB is equal to pi r square minus area of minor segment of APB. Now, let us solve some problems to apply the knowledge that we have learned so far. Problem number 1. Find the area of the sector of a circle with radius 4 cm and of angle 30 degrees. Also, find the area of a corresponding major sector. Use pi as 3.14. In previous problems that we resolved, we had taken it as 22/7. When you actually resolve it, you get it as 3.14. So that is what is being given to us in this problem. Let us look into the solution. The given sector is OAPB. Look at the figure. Area of the sector is equal to theta divided by 360 degrees into pi r square, which is equal to 30 divided by 360 into 3.14 into 4 into 4 centimeter square. On calculating, you get 12.56 divided by 3 centimeter square, which is equal to 4.1 centimeter square. Area of the corresponding major sector is given by pi r square minus area of sector OAPB. On substituting the values, you get pi is 3.14. So 3.14 into 16 minus 4.19 centimeter square, which is equal to 46.05 centimeter square. On rounding off, we get 46.1 centimeter square. So far, we have calculated the area of different shapes or the different figures separately. So in this topic, let us try and learn the areas of combination of planes. So now let us see a question on this. In figure, two circular flower beds have been shown on two sides of a square lawn ABCD of side 56 meter. If the center of each circular flower bed is the point of intersection O of the diagonals of the square lawn, find the sum of the areas of the lawn and the flower beds. Moving on to the solution. Total area is equal to area of sector OAB plus area of sector ODC plus area of triangle OAD plus area of triangle OBC. Substituting the values, you get this is equal to 90 divided by 360 into 22/7, which is the value of pi, into 28 into 56 plus 90 divided by 360 into 22/7 into 28 into 56 plus 1/4 into 56 into 56 plus 1/4 into 56 into 56 meter square. Now, calculating this, we get 1/4 into 28 into 56, open the brackets, 22/7 plus 22/7 plus 2 meter square. Now, we get 56 into 72 meter square, which is again equal to 4032 meter square. So, let us see what we have learnt in this chapter. To summarize, circumference of a circle is given by 2 pi r, where r is the radius of a circle. Area of a circle is given by pi r square. Length of an arc of a sector of a circle with the radius r and the angle with degree measure theta is given by theta divided by 360 into 2 pi r. Area of a sector of a circle with radius r and angle with degree measure theta is given by theta divided by 360 into pi r square. Area of a segment of a circle is equal to area of the corresponding sector minus area of the corresponding triangle. I hope you enjoyed learning with us. For more such videos, keep watching Succeed e-learning app. Thank you.